All right, we're going to go through one example here in this video, and then there'll be a second example which we'll put in another video, so it's not too long. All right, so an aircraft flying horizontally at an altitude of 500 meters, with a velocity of 120 meters per second, releases a package. And it could be a bomb, it could be a relief parcel, or whatever the case happens to be. Though if you drop a relief parcel from that high, it could be a little bit disastrous maybe. And of course, we're not going to have a parachute because that would introduce air resistance. So what have we got? We've got our aircraft here flying along, releases the package there. All right, so we've got an initial velocity. Well, let's just say V. It's a little bit confusing to say U in the horizontal direction because there is no change. So we've got velocity 120 meters per second. And we're trying to find out how long it takes for the parcel to reach the ground. All right, so the parcel is going to go something like that. Now there's the ground. We want to know the time that it takes to reach the ground. Now, if we think about the components, compare this aircraft with a hot air balloon sitting stationary. If you drop the parcel from a hot air balloon and you release the parcel from the aircraft, they should both fall with the same vertical velocity. So in answering this question here, what we do is we consider the vertical motion only. Forget all about the fact that it's moving sideways, okay? Consider the vertical motion only and work from there, okay? So in terms of the vertical motion, what do we know? And this is the very, very common mistake. A lot of people will say U equals 120. It does not. In the vertical direction, U is 0 meters per second. Acceleration, 9.81 meters per second squared. Did we know anything else? I think we did. If we just flip back up the page, we knew the altitude, 500 meters. So we know the distance through which the parcel is going to fall. S equals, and what does the question ask for? Time. Oops, sorry. S equals 500 meters. Get it right? And we're trying to find the time. So we look at those four things, identify the equation of motion, and it's going to be S equals UT plus a half AT squared. The fact that U is 0 makes the problem relatively easy to solve. 500 equals 0 times T plus a half of 9.81 times T squared. All right, so the 0 T bit drops out. We've got taking the half and multiplying through by the other side, 1000 equals 9.81 T squared. T squared equals 1000 divided by 9.81, from which we will get T equals, and I'm going to have to grab my calculator to do the calculation, but you could do the same thing perhaps. All right, so 1000 divided by 9.81, much easier to do if we use G as 10, but we probably should stick to the value of G that we would normally be using. 1000 divided by 9.81 and square root that. Don't forget to square root at the end. That's a common mistake too. 10.1 seconds to reach the ground. Okay, so that's the first part of the problem. Next part of the problem, how far from the release point does the object hit the ground? All right, so there's the release point again. This time, we want to know if that's the release point, we want to know this distance. Let's call it SX, the distance in the X direction, talking about YX, okay? So let's think about that. This one, we're dealing with the horizontal motion. So this time consider horizontal motion only, and that's makes it a very easy problem. Oops. Consider horizontal motion only. So this time the equation we apply, I said before, was that V was equal to S over T. What we're being asked for is S, velocity times time. S in the X direction is the velocity in the X direction times time, and that velocity was 120 meters per second, and the time was 10.1 seconds. 120 times 10.1, 1212 meters. Well, we always sort of worry about sig figs, or we meant to worry about sig figs. 1210 meters, rounding that off to 3 sig figs. Next part of the problem, with what velocity does the package hit the ground? Now be careful here. Here's the package coming down again. When the package hits the ground, it will hit the ground at some angle. And in being asked for the velocity, we need to have our wits about us. We need to be thinking about the angle in here, and we need to recognize that that velocity is made up of two components. That horizontal component of 120 and a vertical component which we don't know yet, but which we could calculate. Now to calculate the vertical component, V equals U plus AT. We're talking about vertical velocity. We're looking for that. U, remember, is not 120 in the vertical. This could be Vy, Uy if you want. We're talking about the vertical direction. So therefore, that's going to be 0 plus 9.81 times our 10.1 that we figured out earlier. Okay, and so 9.81 times 10.1 equals 99.1 meters per second. Don't get to that point in the problem and think, phew, I've done it, because you haven't. You've now got two components which you need to add together. You've got 120 meters per second. You've got, I should draw that one shorter actually because it's a smaller vector, 99.1 meters per second. And we've got our resultant velocity in there. And so Pythagoras, and you can, I think, can finish the working on this, but this velocity here, V squared is going to equal 120 squared plus 99.1 squared, and so you can get to a value for the velocity. And if you want the angle, where would we quote the angle? I would suggest that realistically, the most meaningful angle would be that angle there. That angle there would be the same as that angle there. So as far as the triangle is concerned, let's call it theta. You're going to get that by using the tangent. Tan theta equals 99.1 divided by 120. So again, you can figure out what theta is.